Welcome, everyone. If I get you to put your headsets on, I'll wait till I see all those beautiful flashing lights up high. Excellent. My name is Aaron Peterson. I'm a solution architect here in AWS, and this plans to be another ripper here on stage 6. A few housekeeping duties. If you're having problems with your headsets, please just raise your hand. We'll endeavour to get someone around to help you with that. Mobile's on silent. You might not be able to hear them, but I think the presenters will. And obviously we have our app, and we'd love to get feedback from you. If you really love this session, the only way we know to put more of these types of sessions on is for you to give us that kind of feedback. So at the end of the session, if you log into the app, the session will have a complete survey button, but you won't see that until the last few minutes. Anyway, so without further ado, because it's jam-packed, this one is going to be great about getting generative AI solutions into production, and I'm really interested to hear what Frank and Aaron have to say. So please welcome them on stage.
A real-world journey to scale and impact. In the last 2 to 3 years, we have seen business in the world integrate generative AI into their products. We have seen generative AI early adopters. They jumped in early, they started to build with generative AI before the ecosystem was still developing, and they met and solved the challenges. The reward is that they test their market early. Many of the Gen AI early adopters has already been running their generative AI powered product at scale with a good business model. And their customers looking at them as the leaders and pioneers of their own industries. While going through this journey, the early have developed experiences on every level: product thinking, user experiences, technology, people, and process. Today, I'm delighted to introduce one of the early adopters in Australia, Lexer. So without further ado, let's hear directly from Aaron Wallis, the founder and CTO of Lexer, to take us through their journey.
Thanks, everyone. So thanks, Frank. As Frank said, I'm Aaron. I'm the founder and CTO at Lexer. And today I'm going to be talking to you about our journey of deploying Gen AI throughout our product. Before I do, though, a little bit about Lexer, so the context is important. We are Australia's leading customer data and experience platform. And what that basically means is that we believe that every great customer experience needs to be powered by fantastic data. So we work with retailers and hospitality companies, helping them collect and aggregate all of their customer data from e-commerce, point of sale, customer service, loyalty, call centers, bricks and mortar store engagements, and so on. We enrich that and unify it together and make it really, really easy for marketers to use. And marketers use it across a couple of different pillars. Firstly is we work really hard to help them understand who is their top customer, why are they their top customer, and how do we find more customers like them through acquisition channels. And then once we've acquired them, how do we grow them and nurture them into being those really high value customers? And then how do we retain them and really complete that life cycle? Now, as an organization, we've been doing this for over a decade now in this field. We're processing billions of events for our customers every day. And they're actually interacting with a tool that looks exactly like this. So this is a screenshot of our product. Marketers are logging into this tool on a daily basis to be able to do interrogation on their customer data. In this particular screenshot, we're looking at some Shopify insights, and they're able to sort of look at that and interrogate it, click around, but more importantly, gain some really valuable insights about that behavior and generate segments which they can use elsewhere through their marketing activation, personalization journeys, and so on. However, over the years, one of the biggest problems that we face is our users are really challenged in using the tool because they've got a couple of pretty big challenges ahead of them. Firstly is they're actually very resource poor. So marketing teams, particularly sort of post-COVID, particularly in the retail sector, which we specialize in, they have seen a huge decline in the headcount in their marketing teams. So we've worked with businesses that used to have like 10 people who had broad range of analytics capabilities and marketing and PR capabilities, and now those teams are like 2 people. So the amount of resource that they have to leverage is really difficult. They're also therefore very time poor. They're spread very thin. They have to wake up every morning and they're like, I need to run that acquisition campaign. We've got that new season dropping next week. I've got to put the old season on sale and this and that and this and that. It all adds up into being a very fragmented day for our user. And although they would love to be more data-driven, that's what every single marketer in the world wants to be, the reality is they actually have very little time to do it. And they have very little capability to do it as well, because most of these individuals, they're comms grads and they've studied, come from a creative background or a comms background. They don't come from a data analytics and data science background. And when you log into a tool like ours, you need to know what question you're asking to get the right answer. So when Gen AI sort of dropped back in 2023, we saw a huge explosion when sort of ChatGPT 3.5 came out. And I know I was away at the time. I actually took some long service leave, and I was hiking and camping around. All I had was like a satellite beacon, and I came back from that, came into the office, and everyone was like abuzz with what had happened and what was launched and the reality and impact of the technology that had just arrived. And I was really excited by it. So we immediately put an R&D team together within the organization and started playing with like how we can use Gen AI to overcome those user challenges that I was just sort of talking about. The reality was, though, at that early stage, like AI wasn't very good. It was hallucinating a lot. The token space was really small, so we weren't really able to put much data into it. But it didn't take very long for the overall field to progress. I'm sure you're all aware of just how quickly the space is moving and advancing. So if we look now at the way that our sort of product looks, this is an example of a different area where I've kind of got a segment on the side and I'm looking at some event analytics on product purchase behavior. We see here a little example of Lexer, which is our AI assistant at work, helping us analyze that data. So in this case, one of the things I really love about it is it's helping us do outlier analysis on the data, which is something that users actually have a really big problem with, particularly because we're collecting data from so many different platforms that there's almost definitely some data quality issues in there somewhere that needs collecting and fixing. But equally, we're summarizing insights, and sometimes those insights may not be rocket science in terms of what they're coming from, but we see a huge reduction in the amount of time that users have to spend to be able to get that insight out thanks to that sort of Gen AI capability. So that was two really, really crude examples that we've built into the tool. But what I wanted to share with you today is some of the challenges that we faced in building, kind of going from 0 to 1 on the version number of Lexer, our AI assistant. So I'm going to spend time talking about 5 different things. The first one here is about performance. So I mentioned before when we first started playing around with ChatGPT 3.5, it wasn't very accurate. It hallucinated a lot. We gave it some tabular data and it would spit out some random analysis that had occurred or fabricate some events and whatnot. So we weren't really able to go live with that, obviously. The other thing we were challenged with is like doing enough prompt engineering that would have us actually have consistent results. If I was to run the same query, run the same prompt on the exact same data, would it consistently give me back the same sort of insight so that users could have a consistent experience as they used it? Because one of the worst things that would happen is if Frank logged in and used it and I logged in and used it and we get different insights from the same data, that was something that would be a huge risk for us. The next was kind of around cost. We sort of really had to look at, given the amount of data we were going to have to push through Gen AI platforms and LLMs, we were really going to be constantly using the maximum token space, which means we're kind of really maxing out on the cost of LLMs. So we had to do a lot of forecasting and modeling around whether or not running this would actually work as it scaled. Are we building ourselves a really big problem for the future? And I was secretly actually quite terrified that once OpenAI and Anthropic and all of the other LLMs realized the value that these platforms were generating, that they're actually going to hike up their sort of costs as well, which thankfully actually hasn't happened. Then we obviously moved on to the build of things. So we were asking ourselves, where does this fit in our stack architecturally? How much data are we going to have to expose? Is the APIs that we're going to have to interact with, do they work well with our existing data schemas, or are we going to have to do a huge amount of additional development around that? And one thing that kind of concerned me as well is like, what was the skills in the team that we were going to have? And so I'm grateful at Lexer, we've always had a really strong data science foundation within our organization, given our subject matter. But were we going to have to go and hire out like LLM experts and build foundational models and blah, blah, blah? And I was quite relieved to sort of find that we were able to use most of the out-of-the-box sort of platforms to be able to do that. The two most important things for us, though, given that we are a customer data platform, meaning that we house and process huge amounts of personally identifiable customer data, was what's the privacy impact of this? So when we look here, it's like, actually, are we able to even like process this data through LLMs? Should we be allowed to process this data? Like, are we creating huge privacy concerns for ourselves here? At the time, particularly early in 23 and even some into 2024, a lot of the API's terms of use were still pretty vague on whether or not LLMs were actually retaining the information, learning from information, which obviously was a really, really big concern given the breadth of customers we work with here in Australia and in America as well. And then sort of GDPR kind of plays a role, particularly if we're sort of talking about PII, and it's kind of like there was a lot of vagueness around that. In terms of security, for us, we're sort of asking ourselves, like, actually, like, what are we allowed to send out of our platform? And the reality is that every single one of our clients, when they sign on to the Lexer platform, they're agreeing to us that we're going to protect their data and keep it inside of our AWS architecture and not allow it to leave without their permission. And so in this case, particularly back in 2023, when we first launched it, we had to send their data out to OpenAI. It was really the only platform that we could implement with at that time. So we had to go to each of our customers and actually ask them consent to do it. We had to get them to sign in to that change of terms of service, which obviously a lot of businesses at that time were really, really concerned around. So we initially got very low adoption of the feature, even though the marketers want it, but the legal team were hell no on it. So that sort of pushed us to, unfortunately be a bit limited in our original product design. But the original solution looked a little bit like this. We didn't know it at the time, but we built an early version of RAG. We work with some customers that have a data model that is 3,500 properties wide. And so you can't just put 3,500 data dictionary definitions into a prompt. You're going to fill the space purely out of that. So we kind of did a lot of that sort of early sort of RAG work. We had to do a lot of pre-aggregation of data because we couldn't just upload like 3 million customer records, obviously, into a prompt and so on. So we were already pretty good at that aggregation from that screenshot you saw before. There's obviously a huge amount of analysis and aggregation in there, which led us to having to do a lot of prompt engineering to really get that model right and the predictability of it right. And unfortunately, at the time, we had to do a lot of platform dev. These days, there's amazing tools like Amazon Bedrock and LangChain and PromptFoo and so on that would have made our initial build a lot faster and a lot easier. But kind of being in that early adopter curve, we had to do a lot of that development ourselves. The most important thing is the governance piece. I spoke about that already. From a legal perspective, we just chose to do an opt-in approach to opt into the Gen AI capability. And that led to some low adoption, but some really good results regardless. We built some guardrails into the system to ensure that no PII was ever actually included in the prompts and so on. So that was kind of like a strict policy we put across our deployment. And we made sure that we had a really good feedback loop where users could sort of interact with the results and give us some direct feedback to ensure that we were delivering high quality outcomes. So with all of those things sort of put together, we actually ended up having a pretty successful deployment. So for those of you who might not be familiar with G2 Crowd, it's kind of like a rating platform for enterprise software. So, if you really like the platform you're using or really hate the platform you're using, you can go there and, rank and rate the platform. I personally am really proud to have a 4.5 out of 5 score on G2. But more importantly, when we launched all of our AI capability, we saw a really significant uplift in sort of our general NPS and ease of use scorings. And when I speak to our customers about that today, we know they give us firsthand feedback around how easy it is for them to log in. They don't even look at the tables and graphs anymore. They're actually just copying and pasting the text that Lexi gives them, putting them in the board reports, and off they go, which is a really great outcome. But unfortunately, we're still sort of stuck in that period where we could only get about 60% of our customers to agree to expose their data to an external LLM. And so that's when we started working with Amazon, particularly on Amazon Bedrock, to be able to bring a lot of that processing into our architecture. So today we are actually running on Claude within Bedrock. We've been playing around with AWS Nova. We've got a bit of Llama 3 running around in our platform as well. And I really like how we're able to use all of those different models throughout our platform for specific use cases, depending on like what actions need to happen. So some of the reasons that we kind of led us to choosing Bedrock in the first place was that model diversity that I mentioned. Being able to run Claude and Nova and Llama and any others that we might choose to deploy in the future under that one roof was really fantastic. It really helped us with R&D and experimentation, and even like today, I checked the Slack channels from work, before I jumped on stage, and the team are sort of playing around with some prompt engineering on a new thing, and they're testing out some different models through Bedrock, which is fantastic to see that sort of R&D approach in the team. It's obviously great that it just works, and it legitimately does just work. Like we basically have got approval to use the models in the region, and it just plays in really well with like the security policies and IAM policies and etc., which means that we didn't have to play around with a whole new suite of APIs to interact with. But more importantly, that data privacy and security piece was really significant for us. So we're now able to roll the product out to our users without actually having to change our terms of service, because all of the activity that happens within our AI is actually happening on our architecture without exposure outside of the platform, which is absolutely fantastic. So before I wrap up today and hand back to Frank so he can talk more about the underlying architecture of the solution, I just wanted to share with you some of the stuff that we're playing around with that we're really excited about sort of in the next wave. So we're spending a lot of time playing around with tool use and function calling across the LLMs. I'm really eager to see where MCP goes from an enterprise space in particular. So we integrate and play with some really big data warehouses and other MarTech platforms. I'm really curious as to how what the future looks like for our systems to play together. I'm also terrified that it's just going to be SOAP or something like that. We're really eager to play around with moving Lexi from being reactive to being more proactive. So at the moment you have to go into the platform and Lexi will tell you interesting things about your data. We're really working hard from to turn it into more of a proactive agent, where you might receive a WhatsApp message in the morning to say, hey, there were some really interesting trends in the last 7 hours of your business and so on. And lastly, we're experimenting a lot with smaller LLMs. So I think the default position, particularly I saw it in our engineering team, was to always go with the biggest models, the ones with the biggest token spaces, the ones that have been trained off the biggest corpuses. But actually, over time, I'm having a lot more fun seeing what we can do with the really small ones that are so much cheaper to operate, so much faster to integrate with and to get responses from, because they're actually, in my case, in a couple of examples, actually outperforming some of the larger models. So with that, I'm going to hand back to Frank and talk about the architecture.
Thank you, Aaron, for sharing your insight with our tech community. I think it's a great product innovation story.
Thank you.
Aaron pointed out there's a few challenges he and his team has encountered in the early days of the journey. Working with many AWS customers, trying to integrate generative AI into the product, we know Lexer is not alone. So let's unpack some common challenges and see how you can tackle them with services offered in Amazon Bedrock. We'll go through security and privacy, generative AI application safety, selection, prompt management, and quality assurance, and finally, cost optimization. So whenever we have a conversation with a customer on generative AI, the first few questions are almost always on data privacy. How are you going to manage our data? Will my data be used to train foundation models? Will my intellectual property and our confidential information be kept safe? And will my data be kept in the country? When you use Amazon Bedrock, you can rest assured, Bedrock does not store your prompt or the responses. Because this data is not stored, it will not be leaked, it will not be seen or used by third-party model providers or AWS. And the only data Bedrock stores by default are the operational metrics for monitoring purposes, the usage data for billing purposes, and the sufficient metadata so you can list out the jobs you run in Amazon Bedrock. On data sovereignty, all data you send to Amazon Bedrock will stay in the AWS region. If there's any cross-region traffic happening behind certain features, such as cross-region inference, it will be clearly named, so you won't send data accidentally cross-region. On data security, all communication in transit will be encrypted with TLS 1.2 and above. All data at rest is encrypted, and you can choose your own KMS keys for these encryptions. And you can use familiar mechanisms like IAM to control access to certain foundation models, as well as Bedrock APIs. Many of you today are already running your production workload on AWS. So when you integrate generative AI into your product, you would like the data through private connection. You can achieve this by creating a private link in your VPC. With private link, your applications from your VPC can access Bedrock as if Bedrock is in your own VPC. On governance and auditability, like any other AWS services, you can track Bedrock metrics in CloudWatch. You can track API activities of Bedrock in CloudTrail. So you can always answer questions like who invoked what model and when. Bedrock is also in scope for the most asked compliance standards to help you simplify. I think there's a lot to be said on security. I want to wrap up this security section with some key stats listed on the screen here. So these stats are the outcome of AWS commitment to security. And that is why organizations like Australian government chose AWS to run their top secret cloud. So when you think about the risks associated with generative AI in your application, it's not just about security. Where security is primarily about defending your software and your data against bad actors, Gen AI safety is about controlling the Gen AI's output to prevent it from causing harm. If you worry about the AI model in your application is talking about the wrong thing, which is not aligned with your organization's policy or value, Guardrail is here to help. Guardrail allows you to define safeguards foundation models using your application, which can be applied to both user inputs and model outputs. Guardrail can be used for models running in AWS or outside AWS if you are currently using a model from a third-party provider or if you're running it on-premise. So let's see what it's like. Guardrail can help filter harmful content such as hate, insult, sexual violence, and misconduct. It can help mitigate Gen AI prompt attacks such as prompt injections. And you can configure the filter threshold individually on each different categories. You can define deny topics using a natural language description. Here, I added a deny topic on investment advices. You can also create word filters to filter out a list of specific words. As Aaron said earlier, you don't want to send any PIIs to a foundation model. Guardrail can help detect and redact sensitive information through a built-in PII filter. You can also define your own custom filter with a regex expression as well. Guardrail can help mitigate large language model hallucination problem by checking the reference source you provide. When the generated response from the large language model conflict with the reference source you provide, Guardrail can block that response, so your customers won't see the hallucinated response, and your team can take their own time to investigate the scenario and further improve their applications. So in summary, Guardrail help you to mitigate large language model safety risks and help you meet your responsible AI policies. So now moving on to model selection, prompt management, and QA. The number of Gen AI models today on the market is beyond a simple count. So how can you make sure you can select the right model with the right quality and speed without spending more on inference? And how can you find the best prompt that works best for your use case and be confident to move to a different model when new models and better models come to the market? So the answer is testing. The question is, how can we do this more effectively, efficiently, with reasonable time and cost? Bedrock model evaluation provides automatic and human evaluations. At the beginning of a new use case, you probably want to evaluate a number of models to narrow down your selection. You can use automatic evaluation with traditional NLP algorithms or with a large language model as a judge. Once you narrow down your selection to 2 to 3 models, you can use human evaluation with your own team or with AWS managed team. And you can compare the evaluation results visually in your AWS console and choose the right model. In addition to model selection, the natural language prompt is another important factor that will affect the model output. Many of you have been to some prompt engineering workshops in today's conference. What I would like to call out are 2 things. Number 1 is how can we write a better prompt with the help of a large language model itself? When you create a simple prompt from prompt management or Bedrock Playground, you will see an optimize button. And when you click on it, Bedrock will use a large language model to rewrite your prompt. And this will give you a great starting point to further optimize it to your use case with a more clear instructions and more explicit prompt it generates. The second thing is, how can we keep track of all the variations of prompt and their outputs so we can compare them, go back and forth, and find the best prompt? Bedrock Prompt Management allows you to create variations of prompt and compare them side by side. And here I'm comparing a simple prompt with a more explicit and clearer prompt. The foundation model generates a verbose amount of text from the simple prompt, but gives very structured output from the more clearer prompt, which can be easily consumed by your software and your applications. With model evaluation and prompt management, we're really testing the model and the prompt in isolation. This is like a unit test in the traditional QA process, right? But just like the traditional QA process, there's also integration test and user acceptance test as well. So this is almost the same, but the only difference is in traditional software, they produce more consistent and repeatable outcome, which can be easily verified against a predefined specifications. But generative AI models may produce a variety of different outputs. And when you run the QA process, the goal is to evaluate that output and see if that actually helps the end user to achieve their desired outcome. But that will require your product development team to be more flexible and have more knowledge about your products, your customers, and your business, and also the risk management approach of your business. So it's very important to clearly communicate this information to your product development team and empower them to make good decisions. So lastly, let's talk about optimization. First, is to use the smallest model that satisfies your quality and latency need. Once you pass the initial proof of concept phase, use model evaluation we just covered to choose a smaller and cost-effective model. If the smaller model can do some jobs well, cannot do all the jobs well, consider using a multi-model approach. The gist of it is to use a large model for more complex jobs and a simple model for smaller jobs. If you have different request types, which have a varying degree of complexity, you can definitely code some application logic to make this work. But if you prefer configuration or want to speed up your dev testing cycle with a visual tool, you can also use the tool called Bedrock Flows. So in this example, I created a chatbot for a restaurant. When the user sends a natural language query, it will first be classified into a restaurant-specific query or a generic query. If the request is about the restaurant itself, it will be a large language model in combination with the restaurant's knowledge base. For example, its menu. If it's a generic query, it will be just answered by a generic large language model. So the request classify logic is pretty simple. So I use a small model called Nova Micro for its lower cost and lower latency. But for business-specific queries and generic queries, answering that will be a bit more involved. So I use the larger model for that. I use Nova Pro for the knowledge-based responses and Claude Haiku for the generic responses. And the best thing is not only match different models, you can also test the output directly in your AWS console and deploy it in your AWS console. Another way to implement multi-model is to use Bedrock intelligent prompt routing. This feature allows you to choose a model family instead of a particular foundation model. Here, I use the Anthropic prompt router, which will route simpler requests to Haiku, which is cheaper and smaller, and more complex requests to Sonnet, which is more complex and more powerful, but also more expensive. Depending on your use case, you might have quite a few in your organization. There are different ways to call model inference. In a real-time inference, where latency is very important, you will use on-demand inference or provision throughput if you are operating your application on a very large scale. You might also have jobs like a nightly batch job, where your customers are not sitting there waiting for a response. This will be a good time to use batch inference, which is 50% cheaper than on-demand. And lastly, once your application has been deployed at scale with frequent requests and lots of identical leading text in the model prompt, you can also use Bedrock prompt caching to help you save cost. It will cache the repeated prompt prefixes, which will reduce the token recomputation and therefore save you cost on input tokens as well as latency. In this example, I have a request to summarize a lengthy document. On the left side, without prompt caching. On the right side, with prompt caching. And zooming into the numbers, you can see the difference in input token size as well as latency. In the real world, the bigger your scale, the more you can save with prompt caching. So we are coming to the end of the session. I hope you're inspired by Lexer's journey of building their generative AI-powered products and ready to build your own with the tools we're providing Amazon Bedrock. So if you found you have learned something new in session and want to see more sessions like this, please do the survey and let us know. Here are Frank and Aaron. Thank you very much for coming to our session.
Thank you.